So in case you haven't noticed, there's actually a pattern to multiplying by powers of 10. We kind of touched on this when we were talking about the multiplication table for 10. Like when we said, whenever you're multiplying a number by 10, it's basically that same number back, but with an attached zero at the end. Let's look at why that works. So for example, if you have 123 times 10 the long way, what we would do is multiply everything by zero first. So 0 times 3 is 0, 0 times 2 is 0, 0 times 1 is still 0, because anything multiplied by 0 is 0. Then we'd have a placeholder 0, and then multiply everything by 1. So 1 times 3 is 3, 1 times 2 is 2, 1 times 1 is 1, and then we would add all these together. So 0, 3, 2, 1. So what you'll notice is what we have is what we started off with, which is 123, with an attached 0 at the end because we were multiplying by 10, which has 1 0 at the end. But this would basically happen for any power of 10. So for example, if you're multiplying by 100 instead, what would happen is you'd have another row of zeros, another placeholder 0, and therefore another attached 0 at the end, because 100 has two zeros, and so you have two zeros attached at the end. Similarly, for 1,000, you'd have another row of zeros, another placeholder 0, and then another attached 0 at the end. So there are two ways to think about multiplying by powers of 10. You could think about it as attaching the number of zeros to the end, or you can think about it as moving the decimal to the right that many times. So for example, if you have 174 times 10, because 10 has 1 0, then you're going to attach 1 0 to the end. So you have 174 with 1 0 attached. 523 times 100, well, 100 has two zeros at the end, so you're going to end up with 523 with two zeros attached at the end. Similarly, for 1,000, now 1,000 has three zeros at the end. However, we cannot think about this as just attaching three zeros at the end, because attaching three zeros at the end of a decimal doesn't change the value of the number. So in this kind of case, we have to think about it as moving the decimal to the right three times instead. So we have 3, 7, 9, 8. So you have to move the decimal to the right. So 1, 2, 3 times. And this is where a decimal is going to end up. And any empty spaces need to be filled in with a 0. So we'd have 37,980. Okay. And that's basically how scientific notation works. So in scientific notation, you always have some kind of decimal times 10 to some kind of power. Well, first of all, this power just tells you how many zeros there's going to be. So 6.02 times 10 to the 7th, we'd have to just think about it as moving the decimal to the right 7 times. So we have 6.02, let's move to the right 7 times. So it's 1, 2, 3, 4, 5, 6, 7. So this is where the decimal is going to end up. And any empty spaces, let's fill in with a 0. So what we have is 602 with 5 zeros at the end, which gives us 60,200,000.